Okay, so we've made some a distance matrix. How do we turn it into a tree? Well, simple answer is we use R, which is a statistical package. Looks like this. You write commands and it does stuff for you. It's really powerful for drawing graphs, but at the moment we're going to use it for its phylogeny algorithms. You can just download it. I'll send you the link, and it's quite easy to use if you know what the commands are, and I'm going to tell you the commands. When you first download it, you'll need to install packages, and there's one package we'll need to use for this. So we just type install packages ape in quote marks. We tell it where we are. We're close to Bristol or Cambridge or London, any of those. I actually already have it installed, so it's going to tell me, yeah, great. And then that line you only need to do the first time you download it, but every time you turn it on, you need to tell it to load that. Okay, now we need to get our table. So to do that, you can do various things for opening files, but it's different commands depending on whether you have a text table or an Excel table. And Excel, it's sometimes hard to do. Either way, we'll just do copy paste. So I've selected that, and I'm going to go edit copy. Now the general command for how to bring it into a table in here is the same, but it'll be slightly different on Windows and Mac. First, we need a name for our table. Let's just call it table. Then you do a little arrow, and you type read.table. I'm going to leave just a comma there for the meantime. Header equals true, and the true has to be in capitals. Row names equals 1, because the first column of the area selected is the row names. And sep equals /t in quotes. The separator, the symbol that means this is the end of one cell or one column and the start of the next, is a tab character, and that is represented as /t. Now I left this blank because this is what's telling it where our thing is. So it could be a file path. Now if you're on we're going to tell it that it's going to be the clipboard. Now if you're on Windows, you would just type clipboard. So navneet, you're on Windows, so that's what you would type. If you're on Mac, on the other hand, what you have to do is type pipe, brackets, and in quotes, pb paste. So I clicked enter, nothing appeared to happen. That's good, because if you had something wrong, for example, I just typed pbpe, it'd go, well, I don't know what you mean. But if you have something right, it will just meekly accept it. But we can check that the table is there by typing the word table, and it will print it back out at us. It's kind of an ugly way. If you just want to see the top few lines, you can write head table, and we'll just get the top few lines. But you can see the headings are correct, and these are correct. Though it has removed most of the marks from this, which is a little bit annoying, so I'll have to put those back in later. Okay, now we just need a few little commands to turn this into a tree. First one, we're going to cluster it. So we're going to make a new object called class with a little arrow, and we're going to type this. Now, what that means is we're going to run the command hierarchical clustering. The object we're going to run it on is our table, and we're telling it that it's already a distance matrix. It's not a bunch of things where it needs to work out how the distance. We're telling it we've already done the distance matrix. And the method we're going to use for clustering is averaging. I think I've already explained what that means. Okay. Now, we can actually just plot that in R. I'll show you how to do that just now, just so you can see what happens. And we get something that looks like this. But that's not so useful because it's kind of ugly. We can't color code it or anything. So we're going to export it. So to do that, I always have to look this up, and that's not a terrible thing. You always find people doing stuff in R, and if you're ever confused what to do in R, you can always just Google it. But you can use, there it is. So we're going to take this command. So the command is, and this is why we had to install ape, write.tree phi, let's type as philo, plus. So we've already worked out the phylogeny, and that's the one we're going to do. And then we need to give it a file path in quotes. I've been doing all my stuff in this averaged clustering, and easy way of getting a file path, at least on Mac, is to drag a file from our folder and it will give you the path. But we want to change this to tree.newick. And we click enter. Now in there we'll have a file called tree.newick, and if I open that in TextEdit, I get this, which is a representation of the tree we saw previously. Now it's actually done a pretty good job. It hasn't taken the dots, it's taken the column headings, but as you can see, turn off the spelling check, there's a lot of underscores. We don't want those. We'd rather have spaces, and it's fine to just remove them. So I'm just going to do find and replace to change all my underscores into spaces. And save it again. Okay, now we want to see this tree in a proper tree viewer and colour it in and do interesting things with it. So this is FigTree. Again, there are many software for doing this, but I just use this one because it works nicely. And I can just open that file and it'll give me this. And I can, first of all, change it into a tree that looks a bit more like this, which is a unrooted tree, which can be a lot more reasonable at telling us. It doesn't kind of imply that there was a common, that the thing at the top was the most important. It's probably a more reasonable representation of our data. And we can do things like change the tip labels to have a larger font, and we can spread it out a bit more. That's all fine. And you could color in, so you could find all the ones which are called, you can sort of click that, and let's try and find some more. If I hold down the command key, I can select each one. Yeah, there we go. So I could color in all the ones which are marked as middle, for example. And then click color and make them red if I wanted. It's kind of the way it goes. And I don't really expect individual sections to be that illuminating. Rather, I think once you get, you could consider adjacent sections to be more a tree built out of comparing adjacent sections or something like that. I don't think it's going to be that good off just a single image, but that's the procedure that you use for taking a distance matrix and turning it into a tree, and then being able to play around in this software to make the tree look more like what you want and show what you want.